Okay, so here we go. We're going to calculate the rate of change of r with respect to theta given this polar graph. So this is a pretty easy one because it's asking us for the rate of change of r with respect to theta. And our polar graph is written as r in terms of theta. So you just have to take the derivative as usual. Sometimes I'll ask for dy dx where you'd have to create the rectangular coordinates y and x, but this isn't the case. So we're going to do this, and then we're going to actually try to figure out what it means. So let's work on the derivative first. This is 10 theta over theta squared plus 1, so it is a quotient rule. So I have the bottom times the derivative of the top, minus the top times the derivative of the bottom. The derivative of the bottom is 2 theta, so this would be 20 theta squared, and all over the bottom squared. So I'm not going to simplify this much because I know I'm just trying to calculate this derivative where theta is exactly 2. So I can plug that 2 in as soon as I want, and I'm going to do that now. So plugging theta in for 2, we have 10 times 5, 2 squared plus 1, minus 20 times 4, all over 2 squared plus 1, which is 5 squared, which is 25. So I'm going to simplify. So that's the rate of change at which of r with respect to theta exactly when theta equals 2, negative 6 over 5. So it's a negative, so that means r is decreasing. And remember, r is a distance to the origin. It doesn't necessarily mean you're getting closer to the origin. It depends where r is. We'll talk about that and what r is. But r is definitely decreasing as theta is increasing, and not very quickly. So it's negative 6 over 5. I'm going to rate that a little bit better. So when theta is 2, by the way, r is, let's just figure out what r is. So this is the answer, but I'm going to go a little bit deeper. When theta equals 2, r is going to be equal to, we're just going to plug it in. So 20 over 5, which equals 4. So that means r is 4. That means how far it is from the origin, r. So when theta equals 2, r is 4 units away from the origin. According to the derivative, r is decreasing because it's negative. So that means at the moment theta is 2, r must be approaching the origin because this 4 is getting smaller. Not that quickly, but it's getting smaller. So let's look at the graph just to check it out. That's always a good idea, so you have a good overall feeling for this stuff. I thought I had the graph already graphed. I do. So here's the graph, and we have theta equals 0 at this point. I'm going to increase it. So look at what the graph looks like. Theta is now 3.4. It's getting bigger and bigger. So this is a really neat graph. It's just spiraling in to the origin. So the question we had was what's happening exactly when theta is equal to 2, which is over here. So we're about right here. 2 was around here. Let me just, all right. So this is exactly where 2 is, right here. So when you look at let me clip this so I can, whoa. 1 second here. I'm going to clip this so I can draw on it. Perfect. So according to the graph, this is where r is 2. So this is r. R is exactly equal to 2 here. And theta is, by the way, 2, which makes sense here because theta would be about 1.5 here, pi over 2. So theta would be 2 right here. Oh, I'm sorry. We said R was 4 and theta was 2. So this is where we're at. Theta is 2. R equals 4. Now, this graph is approaching. We saw it's doing this. Whoa. So you can see at 4, it still is getting closer to the origin. Not very quickly yet, but it's getting closer to the origin. So that is what this is telling us. That R is getting smaller at a rate of negative 6.5, or I'm sorry, 6 over 5. So about negative 1 per change in theta. So it is definitely getting smaller. Like you can see right here, it would have been smaller. So that's what's going on. Hopefully that does make some kind of sense. It is always nice to graph these functions when you get the answer, or even before you get the answer, just so that you can see what it actually means. So there's another video where I'm gonna do a similar problem with polar coordinates, but I'm gonna figure out what dy dx is, and that's going to tell us something very different. So stay tuned for that, and I'll see you next time.